Okay, my name is Pedro García López. I'm professor at Universidad Rovira i Virgili in Spain and coordinator of the CloudButton research project. I will give an overview of the project in this internal review, this mid-review after 18 months of work. The agenda or the structure of this presentation will be the following. I will first overview and motivate the project. I will describe our 3 use cases in big data. I will give you an overview also for global architecture and describe the results and impact that we obtained so far. Finally, I will explain some next steps that we plan to do in the next year and a half and describe the agenda for the meeting. Okay, let's explain what is CloudButton. CloudButton is a 3-year research project with a budget of 4.2 million euros. The main goal of the project is to create a serverless data analytic platform. We aim to democratize big data by overall simplifying the overall life cycle of big data applications thanks to serverless technologies. We are going to demonstrate the impact of the project in 3 big data use cases with large data volumes like genomics, metabolomics, and geospatial data. In the project, we can find academic partners like Universidad Rovira i Virgili in Spain, Imperial College London in the UK, or Institut Mines Telecom in Paris, France. We also have large companies like IBM and Red Hat, and others like Atos and Answer. And we have research institutes like the European Molecular Biology Laboratory or the James Hutton Institute in the UK. Here we see an overall picture of the project. We have 3 objectives: creating a serverless data analytic platforms, where we will provide some programming abstractions for transitioning to the cloud and automated tools to simplify this movement. We will create mutable shared data middleware in order to provide consistency over in-memory storage for stateful big data applications. And finally, to create a serverless compute engine supporting high performance big data pipelines and data flows. We will build on top of open source projects backed by companies like IBM and Red Hat, like Apache OpenWhisk, Kubernetes, and InfiniSpan. We will rely on large data sets in genomics, metabolomics, and geospatial data, like satellite data or molecular data sets. And we will demonstrate everything on these 3 use cases on genomics, metabolomics, and geospatial data. To understand why CloudButton, we must refer to a paper that really inspired us to create the project. It's this Occupy the Cloud paper by Berkeley in 2017. This is really the first system that said that you can use function as a service to launch thousands of embarrassingly parallel tasks. And they demonstrated that map-reduced models could be executed efficiently on top of serverless functions and cloud object storage. But we pay attention to this phrase that they have in their paper. Our proposal was motivated by a professor of computer graphics asking us, why is there no CloudButton? And he outlined how his students simply wish they could easily push a button and have their code existing, optimized, single machine code running on the cloud. This phrase inspired us a lot. So you see the name of the project. And we said, we want to realize this vision from Berkeley and go beyond what they provide with Pyren, this tool to move map-reduced tasks to the cloud. So our first step was a collaboration between IBM and Universidad Rovira i Virgili, Gil Bernick and Josep Sampé, in creating a version of Pyren for the IBM cloud. Initially, it was just a porting, but it has grown to something larger and much more advanced than the original Pyren. We published this in the middleware conference, and we are building on top of this work. And that's why the project, it's evolving so fast, and we will show a lot of results in this review. But let's first start describing what is serverless, because this is what the technology that we are building on. So there are different definitions. Amazon, that is the creator with Amazon Lambda in 2014, provides 4 features for defining serverless: pay for value, automated high availability, no server management, and flexible scaling. I like more the IBM definition in this paper in the rise of serverless computing, because it's more concise and we can understand better what we are talking about. So they say serverless computing is a platform that hides server usage from developers and runs code on demand, automatically scaled, and built only for the time the code is running. These characteristics are essential to simplify the execution of big data applications in the cloud, as we will see. Why serverless? I must outline 3 major advantages of using serverless. The first one is simplicity and productivity. Since there is no server management and we have flexible scaling, it will be much easier to move applications to the cloud without provisioning them. So simplicity and productivity, this democratizing big data, it's the major advantage of serverless technologies. The second one is scaling and performance. We can really launch thousands of functions, execute some task, and shut down and scale to 0. And really, there is no other cloud technology where you can launch 1,000 functions in parallel and stop. And this can really help a lot of the big data use cases for scalability and performance. Also accessing petabytes of data in cloud object storage very fast. Finally, cost. This pay-as-you-go model, where you only pay for the resources that you are using, can be really suitable for many big data scenarios. So we will explain in our use cases why we are benefiting for these 3 characteristics. Of course, everything is not that perfect. So there are trade-offs in using serverless computing. So I outlined this position paper that the consortium write together, Server Mix, Trade-offs and Challenges of Serverless Data Analytics, where we, in the beginning of the project, we analyzed the state of the art and these trade-offs of using serverless. And of course, we realized that serverless is very good for some scenarios, but in other scenarios, serverful can be more appropriate. For serverful, we mean the traditional virtual machines that can have to be provisioned on the cloud, or cluster technologies, where we have a cluster of virtual machines in the cloud using technologies like Apache Spark and others, where you normally have a lot of configurable memory and compute at your hands. Unlike serverless computing, where memory is limited and then you connect to disaggregated storage. Even we have cases for this server mix definition that we say that where you want to combine both worlds. For example, even many works on serverless data analytics rely on serverful components like in memory layers. Or even when you have legacy code in a serverful environment and you want to combine it with serverless technologies. Even more, sometimes serverful is cheaper than serverless for some tasks. So we will try to combine both worlds, relying and benefiting from these characteristics of serverless and serverful environments. We have 3 use cases in the project. The first use case is metabolomics. And this is our flagship use case, our big success story in this project. In the beginning of this project, we paired every use case with a technical partner. And we paired EMBL with IBM. Metabolomics, they had a previous European project, a very successful one, that it's Metaspace, that it's popular in this field with a lot of data sets and experiments there. They were already intensive users of the AWS cloud, using Apache Spark, VMs, and a lot of Python. And their goal was to simplify how they executed these big data experiments in the cloud, and also to consider scalability and cost issues. They have three experiments, like all use cases, about metabolite annotation, data analytics, and molecular discoveries using machine learning and deep learning techniques. And we will demonstrate, as you will see during this review, that we really achieved the goal, combining serverless technologies to simplify a lot the execution of big data applications using serverless technologies for metabolomics. Second use case is genomics. We have the Hutton Institute, and we pair them with Imperial College London. This is again another use case with large data volumes, a lot of legacy code, and they mainly rely on HPC environments and internal clusters, and their goal is scalability. They are limited by the resources in their institutions, and they want to go further using these serverless technologies. And they have also a problem of existing code and pipelines in genomics. So we will see how the combination with Imperial College technologies in serverless has been really fruitful. They also will present three experiments too about livestock functional genomics, virus-host interaction, and cancers of the immune system. Our third use case is geospatial analysis. Here we have two companies, Answer, and we have the Fundación Matrix. And we have paired them with Universitat Rovira i Virgili. In this case, basically they will rely on data sets from satellite data from Sentinel-2 images and LiDAR point clouds. They previously used local computing resources, but they want to transition to the cloud, and they want simplicity, cost, and scalability. They have several experiments that we implemented on serverless technologies, like high-resolution hybrid land cover mapping, 3D fuel mapping for forest fire risk assessment, and mapping water use footprint in a region with climate change problems and water scarcity. So these results are important and applied to real use cases scenarios. These three use cases have been presented as success stories to BDBA association. Let's describe the architecture of the CloudButton project. This is the structure of the work packages. Work package 2 is transversal, where we have the global architecture, prototyping, the testbed of Atos, and we have the different use cases that I have already explained. Then we have the three technical work packages. WP3 from IBM, where we have the high performance stateful compute engine, instrumentation, operation support. We have here Atos helping with monitoring and instrumentation and quality of service. And then we have WP4, where the leader is IMT, with this consistent mutable shared data on top of in-memory computing, where Red Hat is collaborating with their experience in infinite span in-memory computing layer. Finally, on top of everything, we have WP5. The leader is Imperial College London, and they are working on this CloudButton toolkit with the different programming abstractions and tools to move to the cloud. The idea that I want to transmit you is that we are realizing Berkeley's vision, but we are going beyond them. I mean, you remember this text, this push a button and have their code existing, single machine code running in the cloud. Pyren was not that. I mean, it was simplifying how to move applications to the cloud, but you still need to learn some Pyren APIs and interact with object storage using their APIs. We are going further. We presented this position paper, Serverless Endgame, Disaggregation Enabling Transparency, where what we are claiming is that serverless disaggregation of computing resources is the real enabler for full transparency in the cloud. And what means full transparency? It's hiding distributed system complexity and be able to run unmodified single machine applications over effectively unlimited disaggregated compute, storage, and memory resources. The idea is if we can have this full transparency and we can treat local entities as remote ones, you don't need to learn new APIs. Use your local programming model and we will transparently move to the cloud. And what is the magic? When you launch processes in your computer, we launch containers in the cloud transparently. When you use storage, files and directories, we transparently access cloud object storage. And when you are accessing the memory, we access this in-memory disaggregated remote layers. And as you will see during this review, we have achieved that for a number of use cases. The architecture of the project has been organized in three main pillars. We have a pillar that is focused on Python technologies and Jupyter notebooks. IBM and URB are working intensely here, basing their works on IBM Pyrene, but going beyond. As I said, we are intercepting Python programming libraries like the multiprocessing API. Then we have IMT and URB collaborating in Java technologies around the crucial serverless framework, where we intercept again the Java concurrency libraries, and then we move Java applications to the cloud, like machine learning applications on top of these APIs. And finally, Imperial College, it's working on WebAssembly. That's a very ambitious technology because it's more than one language. It's an intermediate language where you can compile a lot of languages there. And then you intercept POSIX calls to use these disaggregated serverless resources. These three blocks, these three pillars, interact with these serverless disaggregated resources like compute, like object storage, like in-memory storage, like InfiniSpan or Redis. We already published papers demonstrating this, and we have today two really high impact publications, one from Imperial College, FASM, Lightweight Isolation for Efficient Stateful Serverless Computing, Usenix ATC 2020. And we have another from URB and IMT on the fast track, building a stateful distributed application with serverless architectures. That it's this work on Crucial, published this year, the last year in the Middleware 2019 conferences. The glue of the three pillars is the use of the serverless compute resources. I will explain that Kubernetes and Knative technologies are going to become a glue for all partners that execute things in a disaggregated way in their different programming environments. But how we glue everything together? I mean, we have different components from different partners. And I also discussed about serverless and serverful components here, legacy code and serverless code. How can we glue everything together? And the word is, the solution is serverless orchestration. When we move big data applications to the cloud, we need technologies that enable to move these workflows, this life cycle of these applications, where you have, for example, conditionals, or you have parallel for joins like MapReduce works, and you continue, you have a workflow or a big data pipeline, and you want to move it to the cloud. So we first studied the different existing technologies in the cloud providers, like step functions, durable functions, Google Cloud Composer, IBM Function Composer, to see if they were good solutions to move these big data applications to the cloud or orchestrate serverful and serverless technologies. We have two papers here in the International Workshop on Serverless Computing in 4 and 5 versions of this workshop, where we demonstrate that these tools are not suitable for high performance, long running big data workflows. They have not designed for that. They have been designed for enterprise workflows, asynchronous one, not for the big data pipelines. So we propose a serverless orchestration layer that can be useful for service integration, server mix idea of combining serverless and serverful with this orchestration. but that can also support high performance big data pipelines with thousands of parallel functions and synchronizing statefully all these parallel functions, but also supporting long running workflows during minutes or hours, uh, and fault tolerance. Pyren, it's not designed for this. So Pyren, for example, cannot support long running workflows or fault tolerance because the controller must be running in a notebook all time. So we want to overcome this project, these problems using serverless orchestration. And we have first results here again. So we published a paper in the Distributed Event-Based Systems Conference called Trigger Flow, Trigger-Based Orchestration of Serverless Workflows this year, where we present an event-based architecture that is serverless orchestration of workflows that can connect different components if you have events that glue them. And all of this was created on top of Knative technologies like Knative eventing. This will be the key glue for the different components of the project, where we will link different technologies using this kind of serverless technologies, serverless orchestration technologies, where we can connect different kind of applications in different languages and platforms. You will see in the use cases that we are already experiencing with technologies in serverless orchestration like Argo and Airflow that are going to be integrated in this whole big picture. We also provided, IBM did a nice work also transparently moving notebooks to direct acyclic graphs in a semi-transparent way to simplify how we really transition to these workflows in the cloud. Let's review the major results in this year and a half. First of all, we have key publications that I already mentioned before. We have this Middleware 19 conference where we publish this crucial framework. We also have this paper in Middleware 2 in WASC where we analyze different serverless orchestration technologies. Then we have Trigger Flow about serverless orchestration in depth this year. And we have FASM presented also this year in ATC 2020. We also published serverless elastic exploration of unbalanced algorithms in IEEE Cloud and different position papers that explain what we are designing in this project. There are more publications, but I don't have a space to outline them all. We also have open source projects where you can see the results. And these are not the research prototypes that are going to be abandoned in 2 years. Many of these projects are backed by commercial companies like IBM and Red Hat and have really lively communities and a lot of use cases from many third parties. IBM Pyren is a popular now open source project with third-party contributions and applications in proteomics, in metabolomics, in geospatial data, and many others. Infinispan and Crucial, led by Red Hat, are also popular technologies in the Java ecosystem. And then we have FASM, and we will show also a CloudButton benchmark where we compare even between different clouds. Dissemination events. We have the Strata Data Conference, where IBM and EMBL saw the metabolomics use case. We have presentations in Intel Labs and IBM Watson Research, and different presentations in different key events from the different use cases. I outlined that even we had a lot of dissemination and impact in this year and a half, we expect much more dissemination activities in the second half of the project. Finally, I want to IBM Watson Research as an important place. Well, you see here my background. This is not a photo. I am in the US now, in Connecticut. I came here on a sabbatical year as visiting a scientist to IBM Watson Research. And I came to the hybrid cloud group because they are expert on serverless computing. I mean, they created Apache OpenWhisk. They are now core contributors to Knative eventing, And they have key articles like the rise of serverless computing and the serverless trilemma. They are also leading the community, leading the international workshop on serverless computing. My year here has been very important to have time to disseminate the project and learn from IBM, both here in Watson and in Zurich with their works on Pocket. And to be able to disseminate, and now I am part of the organizers of the WOSC serverless workshop, and our impact will be higher thanks to this opportunity in IBM Watson. What is next in CloudButton? I will say for the second half of the project is integration. One important thing, and I outline here multi-tenant Knative technologies that are going to revolutionize the serverless setting in all cloud providers. These technologies are going to become really a standard across clouds. And we see here, you will see in the demos that Atos is contributing to Knative monitoring of our serverless runtime. In Finispan in Red Hat, they have created Kubernetes operator to integrate Kubernetes inside this Knative ecosystem and offering auto scalability to applications. The three blocks, Java, Python, WebAssembly, Imperial College, IBM, IMT, will be built on top of Knative technologies. So we will connect also with serverless orchestration in Knative all the services and use cases that we have presented here. And I don't want to spoil or give highlights now or headlines before time, but the second part of the project is going to be really promising, and I expect long-lasting impact for this project. I must say that I have coordinated 3 European projects now, and for sure, this is the more successful one that I've ever led. We are going to demonstrate full transparency in different environments. In Python, we are going to demonstrate how existing toolkits like scikit-learn can be run on unmodified, undisaggregated resources. And these unmodified applications in the cloud is going to change everything. You don't need to use or learn new APIs, use your existing toolkits, move them to the cloud. We will also demonstrate other HPC applications like MPI or OpenMP on top of these FASM technologies in a transparent way. And an interesting thing, we are not aiming one single cloud. We have provided implementations of this extensible framework for different storage and compute backends in different cloud providers. So we support all cloud providers now, the major ones like Azure, Google, Amazon, Alibaba, and we can run our applications unmodified on top of many of these clouds. As a result of this portability and multi-cloud support, as I said, we are going to publish a CloudButton benchmark where we will compare the different clouds using big data applications. We also will publish soon a paper on this comparison. So let's finish now with the agenda of the meeting, now that you have an overview of where are we and where are we heading now in the next years. First of all, we will leave you a set of videos available by the end of July so that project officer and reviewers can watch them carefully. So this CloudButton overview, we will provide use cases and demonstration. We have videos for the 3 use cases. Then the technical work package is like IBM in WP3 or IMT in WP4 or Imperial in WP5 will demonstrate and explain in their video their work package. Red Hat will explain dissemination and exploitation. And then we will also show you a video on management and financial issues. And we will leave you another additional materials if you like to really know the contributions of the project, but they are optional for the review. Because we are offering these videos online before the review in September 9, 2020, the idea is not to replay these videos during the review in September. So the idea is that we will be able to assume that the reviewers could watch these videos. So then we will introduce participants. I will present this introduction again with updated news probably. Then we will leave some time for questions and answers of the videos that reviewers have watched before. We will have some dissemination again, innovation radar, and then in the afternoon, we will go to financial aspects and management, some concluding remarks, and then questions and answers with reviewers and the reviewers meeting and the presentation of results. See you in September in the review. To conclude this presentation, I can only say that I'm happy to coordinate this project with these excellent partners. We have relevant software outcomes in the first half of the project that will have a lot of impact and will demonstrate this impact in the second half. But we already have the top publications that demonstrate our results. We have high impact dissemination and use cases that are success stories. I mean, we will explain you now in the videos how serverless technologies really simplified and provided more scalability to these big data use cases with large data volumes. And finally, really the high impact of this project is in achieving this transparency in different programming models and really simplifying and making straightforward this transition to the cloud from many big data applications, thanks to the disaggregation of serverless technologies. So thank you for your time, and see you in September.